So, good evening, everyone. Welcome back to the online certification course of NPTEL on the topic water and wastewater treatment. So, currently we are in week 4. So, we have seen 4 weeks of lectures till now. And as you all know, the course instructor is Dr. Bhanu Prakash from IIT Roorkee, and I am Akash Saha, one of the teaching assistant for this course. And I am a PMRF scholar at the Department of Civil Engineering at IIT Madras, where I am pursuing my PhD in environmental engineering. Okay, so we will quickly see the contents of week 4 lectures. Okay, so we started with the primary settling tank design. What are the different parameters? What is the design criteria? So that's how we finished the primary treatment section. And then we started with the biological treatment, how the BOD and nutrient removal is being done. Okay, what are the various methods? We learned about the activated sludge process, where we typically have seen the material balance for an aeration basin. Okay, where the aeration and the degradation takes place. So that material balance we have seen. And then we have also learned about the oxygen transfer. What are the various types and basic principles related to it. So today again, we will solve some multiple choice questions, and with that we will also solve some numerical type of questions. Okay, so let's see, and as and when if you have any doubts, please unmute yourself or write it in the chat box so that we can discuss, right? So I'll start with the questions now. Okay, so the first question, it says that which of the following are attached type of treatment system? Okay, so we have the activated sludge process, trickling filter, oxidation pond, and rotating biological filter. So which of them are attached type? So in treatment systems, we have two types of treatment systems. We have the suspended and we have the attached type. So here it is asking about attached type. So I got one answer, B and D. Okay. Any other opinion? So he's saying that trickling filter and rotating biological filter. Any other opinion? Anyone else? Okay, so as he has correctly mentioned, the correct answer is trickling filter and rotating biological filters. Okay, so or they are also called as rotating biological contactors. Okay, RBCs, that is the usual name. So these both are attached type, whereas the activated sludge process and the oxidation pond, these are suspended types. Okay, so here the biomass keeps on moving throughout the system. So if we have an aeration tank or whatever tank we are providing, the biomass will be freely moving in the system. Okay, and so can someone tell me which will be more efficient, a attached type or a suspended type? Which will be more better in BOD or COD degradation? Which will be much better, more efficient? Can we guess based on this, if all the parameters are kept constant, which one can be more efficient and the reason? So here I have written that an attached type treatment system refers to a wastewater treatment process where microorganisms responsible for breaking down the organic matter adhere to a solid surface like a plastic media or rock within the treatment unit, forming a biofilm. Okay, and as the wastewater flows over it, the biological degradation happens. For example, in the case of trickling filters or rotating biological contactors, which are considered as the attached growth system. Whereas in a suspended system, the biomass can easily float throughout the water. So, okay, I'll ask one more question. Where do you think the retention of biomass will be more, or the retention of microorganisms will be more in attached type or suspended types. Can you understand what I mean by retention of biomass? Where do you think the biomass concentration will be retained for a longer period of time? In suspended growth or attached growth? Any idea? So I'm just trying to convince you like which will give a better efficiency. Okay. Be in terms of BOD removal or nutrient removal, which one will give a better efficiency? So that is my question. Any idea? Where do you think attached growth? Yeah, definitely. So what happens is in a suspended growth, since the microorganisms are free to move in the system, there are chances that they will wash out. They will go out from the outlet pipe, the outlet pipe. Okay. Whereas in an attached growth system, there are plastic blocks or media are there present in the system. So the microorganisms will stick over the surface. So what happens is, I will just give a small example. Suppose this is the media. Okay. So over it, there will be a kind of biofilm that will be forming. Okay, biofilm will be forming, and as the wastewater will flow through it, the degradation, it will come in contact with this biofilm and the degradation will happen. Whereas in any other tank, in any other at a suspended growth tank, the microorganisms are free to move throughout. So there are chances that it will come out of from the outlet. Then that's why in ASP we will again recycle it back. So this recycling is done so that the biomass concentration is maintained in the system. Whereas this kind of issues are not there in the case of attached growth system. Okay. So that's what I wanted to tell you. Okay, so now the next problem. So next problem says that it's a small numerical actually. A certain type of bacteria multiplies by dividing into two cells every 10 minutes. Okay, so every 10 minutes it will divide. If you start with 2 into 10 to the power 5 bacterial cells in a petri dish, how many cells will be there after 40 minutes? So they are asking you within 40 minutes from 2 into 10 to the power 5 up to how much bacteria can be formed in a petri dish if the multiplying time, like it will divide into two cells within 10 minutes. So it's a basic algebraic kind of question. Okay, it's not a conceptual environmental conceptual question, but you can easily do it with mathematics. Though a formula is there, but you can just think about it and do it in terms of mathematics. Can someone tell me the answer? Just think logically and try to solve the question. No need to memorize any formula. Just logically think. A. No, A is not the correct answer. Just see, I think you are making a small mistake there. D. Yeah, absolutely. D is the correct answer. So how did you do it? So simply, okay, just a minute. Yeah. So first I will show you the formula. What is the formula? So this is the question number 2. So this is nothing but exponential growth. So the exponential growth formula, that is nothing but NT is equal to N naught into 2 to the power T by D. Okay, so this is the final number of cells. This is the initial number of cells. This T is nothing but the time given. Okay, for how much time, in minutes or whatever. And this D is nothing but the doubling time, in how much time it is doubling. Okay, so simply if you put the values, so my n at 40 minutes, n at 40 minutes will be n naught, that is 2 into 10 to the power 5 into 2 to the power t. The time is 40 minutes, by doubling time is 10. Okay, so this will turn out to be 3.2 into 10 to the power 6. So this is how we have to do it. So now if we think it logically, what will happen? So doubling time, if you see, doubling time is 10 minutes, right? 10 minutes is the doubling time. So you have to find out for 40 minutes. So how many times it will double? So 20, 30, 40. Okay, so 4 times it is doubling. So first in 10 minutes, then 20 minutes, then 30 minutes, then 40 minutes. 4 times it is doubling. So what will happen? Whatever is my initial, so in the first 10 minutes, it will double. So it will be into 2. Then in the next 10 minutes, again into 2. Again in the next 10 minutes, again into 2. And finally in the 40th minute, it will be again 2. So it will be 2 into 10 to the power 5 into 2 power 4. Okay, so same thing. Here also we are getting 2 into 10 to the power 5 into 2 power 4. So that's same thing. So simple mathematics, you can solve this problem. Okay, I hope it is clear. So I have given you the answer here. Next problem. A wastewater treatment plant has effluent MLSS, that is the mixed liquor suspended solids, as 5,500 milligram per liter. After a settling period, the volume of the sludge in the settling tank is measured to be 450 ml per liter of mixed liquor. Calculate the sludge volume index for the given mixed liquor in ml per gram. So SVI, or the sludge volume index, you have to find out. So tell me what will be the answer. And you have to find the answer in milligram per milliliter per gram. Okay, so take care of the uh, units. So what will be my SVI? So what is the formula for SVI? How do we define, or what is the formula? Any answer? It's a very simple calculation. Just you have to divide, but you should know what to divide with what. So what is the volume given? 450 ml. Okay, per liter, whatever. And what is the mass given? That is the MLSS, 550 milligram. That is also per liter per liter. Okay, so simple. So SVI is sludge volume by MLSS or the mass. So volume by mass you have to find out. So it will be 450 by 5500. So it will be 0.0818 milligram per milliliter per milligram. This will be the answer, but we need the answer in milliliter per gram. So just do into 1000. So it will be 81.8 or approximately 82 milliliter per gram. Very simple. Just have to divide it. Okay, so please make a note of these type of questions because these will be definitely, they are very simple and direct questions that can be asked. Okay, so I have few more questions in the later half. So that time you please try to solve. Okay, so 81.8 milliliter per gram. Next question. In biological nutrient removal, what is the purpose of using anoxic zones in biological treatment processes? Okay, so is it to promote the growth of aerobic bacteria, to facilitate denitrification, to enhance phosphorus precipitation, or to optimize ammonia oxidation? So why do we need a anoxic zone for a biological treatment system? Please give the answer. Guys, please try to answer. Otherwise, there is no point of discussing. Just whatever you feel like, write it in the chat box. We can discuss. Okay, that's how we can improve. So just don't just sit and watch the video or whatever lecture is going on. B. Okay, very good. So basically it is done for denitrification. Okay, because for the growth of aerobic bacteria, we need an aerobic zone. Definitely. Okay. Uh, is there any oxygen present in the anoxic zone? Can someone tell me? Is there any oxygen present in the anoxic zone? And if not, what is present in the anoxic zone? Any idea? When do we say a zone is anoxic? What is present there? So we are,
Absent, sir.
sorry,
Absent. Oxygen is absent.
oxygen is absent, definitely. Then what is the electron acceptor?
Nitrous sulfate,
Yes,
carbon dioxide.
definitely. So we have three different kind of zones. We have the anaerobic, we have the aerobic, and we have the anoxic. So we need anoxic zone for the denitrification. Okay, so in anoxic zones where dissolved oxygen is nearly absent but nitrate is present. So the facultative bacteria, okay, so facultative bacteria can survive in both, in a little bit of aerobic zone also and anoxic zone also. So facultative bacteria use this nitrate as the electron acceptor instead of the oxygen, and this reduces the nitrate to the nitrogen gas, okay, which is released harmlessly into the atmosphere. So that is what happens. So that's why we need an anoxic zone, right? Okay. Whereas in an aerobic atmosphere, we will be growing more and more aerobic bacteria and more oxidation will happen. Okay, from ammonia to nitrite to nitrate, like that, oxidation will happen. Next one. Calculate the specific growth rate of microorganisms per hour in an activated sludge wastewater treatment system where maximum specific growth rate is 0.4 per hour, half saturation constant is equal to 12 milligram per liter, and substrate concentration is 6 milligram per liter. So a very direct question, you have to find the specific growth rate or mu. I'm telling you, you have to find out the specific growth rate or mu. So if you know the formula directly, you can answer it. So please solve it. It's a one line answer. 0.13, definitely. Yeah, that is the correct answer. So for others, I will just give you the formula. So it's question number 5. So to find out mu, okay, we have the Monod's equation, mu max S by Ks plus S. Okay, so this is the maximum specific growth rate. This is the substrate concentration S. Okay, and this is the half saturation constant. Okay, this is the half saturation constant, right? So simply if we put the values, 0.4 plus 6 by 12 plus 6. So the answer is 0.13 per hour. Okay, very simple. So this is the correct answer. Next question. In a wastewater treatment plant utilizing facultative ponds, what is the unexpected challenge that might arise during the winter season in northern regions? Okay, so we have a facultative pond. So what can be a problem during winters? Enhanced microbial activity, reduced treatment efficiency, increased pathogen removal, improved settling of solids. So please answer the question. Okay, I got one answer as B. Yeah, so most of you are rightly pointing out it will be B. Okay, so what is the reason? Can someone tell me what is the reason for this reduced treatment efficiency during winters?
Colder temperature.
Okay, so because of that, what will happen? Because of the colder temperature, what will happen?
Microbial activities will reduce.
Yeah, microbial activities will reduce, and
Ice formation.
ice formation. Yeah, that is also that can be a thing. And uh, okay, what? How would you relate to the settling of solids? Will it be more or less during winters? Can you think about it?
Less.
Why? Settling of solids is not uh, correlated with the microbial activity. Then how the settling of solids will be less? What is the reason? Okay, so answer is correct. So settling of solids can be less because the colder water is more viscous. Okay, so this viscosity can increase the resistance for the solids to settle, and hence will decrease the sedimentation or even the sludge dilution. Everything will be reduced. So definitely the primary reason is microbial metabolism, which will slow down during low temperatures, and it will directly affect your removal, nitrification, denitrification. Everything will be getting uh, getting reduced, right? Okay, next problem. A completely mixed flow reactor is designed with the following data. The Q naught or the flow rate is 20,000 meter cube per day. BOD after primary sedimentation tank is 180 milligram per liter. BOD of the effluent is 10 milligram per liter. The yield is 0.5 kg per kg. The decay constant is 0.05 per day. MLSS is 4000 milligram per liter. Underflow concentration is 10,000 milligram per liter for secondary sedimentation tank, and the mean residence time or the MCRT, BSRT, it is 8 days. So what will be my reactor volume? So all the data are given. You simply have to put it in the correct formula and get the volume. So please try it out. I will wait for a minute, then we can discuss. No, I don't think 940 is the correct answer. No, not near 940. What is the formula you are using?
Hello.
Yeah,
Sir, V is equal to 2000 multiplied by 8 days
no, no, not like this. How?
upon.
2000, where it is, first of all, the Q is 20,000 and
Yes.
8 days, no, 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 no. 8 days is the mean cell residence time. It is not
Okay.
the HRT. It is not the HRT. HRT is different. HRT
Okay.
is not given in the question. Okay.
Okay. Okay. No, I just use V is equal to
No, no, no. I understood.
was.
No, not that is not the correct answer.
Okay. Okay. Okay.
Okay.
Yes.
So HRT we generally denote it by theta, not by theta c. Theta c is the mean cell residence time, or the BSRT, or the sludge retention time SRT. We can say it through anyway. So I will tell you, the actually all these derivations are already being taught in the lecture, so I'm not going through it once again. So for the solving questions, just remember, for any activated sludge process kind of problems are there. So the formula is Vx, okay, volume into the MLSS, is equal to theta c into S naught minus S Q naught Y by 1 plus, you can write Kd theta c. Kd theta c or 0.05, whatever is given, Kd theta c. So this is the question. This is the formula. Okay, just make a note of it. For exam point of view, no need to know you don't have to know the derivation. At least this formula you should be knowing. Now you have to just play with these terms. In some places, what they will do, they will not give you the this flow rate. Okay, flow rate will not be given or volume is not given. Instead, Q by V theta will be given. So theta there would be HRT. Okay, so if I take this V to here, okay, this side, so we can put replace it with theta. So like that, they will change the problem. Okay. So I have one kind of problem in the later section also. So we will see. So this is the basic formula. So you just have to input. So V is not known. So V into X. X is 4000 is equal to theta C is 8. S naught is A180 minus 10. Q naught is 20,000. Y is 0.5 by 1 plus 0.05 into 8. So if you solve it, you will get V as 2428.57 meter cube. Okay, so direct formula you have to do, but you have to put the formula correctly. So that is the thing, right? I hope it is clear. So any activated research problem question, you have to apply this formula. So this is the one. Next question. Heterotrophs are, so there are two statements. So statement A says heterotrophs are organisms that cannot produce organic compounds from inorganic sources and therefore rely on obtaining preformed organic molecules from external sources. And statement B says autotrophs are organisms capable of synthesizing organic molecules from simple inorganic substances like carbon dioxide. So you have two statements. You have to tell me which one is true or which one is false, like that. So see the options and tell me the correct answer.
Statement A and B both are true.
Statement A and B both are true. Definitely, yeah. So that is the correct answer. C, because these heterotrophs, what they will do, they will be depending on external sources for organic carbon for their energy and growth. And whereas autotrophs, they will produce their own organic molecules using the inorganic substances like CO2. So this is how they are defined, heterotrophs and autotrophs. Very simple classification. Next problem. Okay, so this questions looks very big, but it's just data that is given, because in the next question we'll need a lot of data for to solve that question. So all the datas are given. The question itself is not very big. So a wastewater treatment plant is set up in Jaipur, where the elevation is 431 meter and the annual average design temperature is 25 degrees Celsius. The plant has a standard oxygen transfer rate SOTE of 45 kg of oxygen per hour with parameters alpha and beta. The saturation concentration of the wastewater temperature and elevation is 9.5 milligram per liter, and the saturation concentration at wastewater temperature of elevation at the standard elevation is 12 milligram per liter. The pressure at full depth of air release is 125 and the atmospheric pressure is 106 kPa. The percentage of oxygen in air leaving the water is 19%, F is equal to 1, and the concentration of dissolved oxygen in the wastewater is 4 milligram per liter. So now you have to calculate the average oxygen transfer rate in the aeration tank. Okay, so in these type of questions, what they do, they will give you the standard oxygen transfer rate. Okay, so each pump or each aerator will have their standard oxygen transfer rate, but according to the temperature, pressure, the elevation, everything, the actual or the average oxygen rate will vary, right? It will vary. So all these data are given just to calculate the average transfer rate. Okay, is nothing but direct formula application. So don't have to worry. You have to know which are the parameters and where to put them. So based on the oxygen percentage, the pressure at full depth, the pressure of atmosphere, we will first calculate the what is the average concentration. Okay, the average concentration. And then with the average concentration, we will find out the transfer rate. So just a pretty long formula, nothing else. So okay, I will not wait much for this because it's just the formula. So I will just tell you. So question number 9. So first we will find out the average concentration, that is the C average. So it is nothing but C at the standard temperature and pressure into 0.5 into PD, that is the pressure at full depth by atmospheric pressure PATM, plus the oxygen percentage by 21, because 21% oxygen is there in air, so that's why we are dividing by 21. So it is 12 into 0.5, 125 by 106 plus 19 by 21. So we'll get it as 12.5 milligram per liter. So now once you know the C average, you just have to put it. So we have to calculate the AOTE, or the average oxygen transfer rate. So it is nothing but equal to SOT, that is the standard oxygen transfer rate that is given in the question, into beta CS minus CL into alpha F 1.024 T minus 20 divided by CS at 20. CS at 20. So simply you just have to put all the values. So it is 45, 0.85 into 12.5 minus 4. Alpha is 0.6, F is 1 into 1.024. Temperature given is 25 minus 20. Okay, divided by the CS20 is 9.5. So we will get the answer as, so my AOTE will be equal to 21.2 kg of oxygen per hour. So I think a similar question is there in your uh, assignment also. So that's how you have to do it easily. Okay, make a note of it, right? We will move forward now. So the same thing is given. So here much clearly you can see the formula and everything is given. Next question. Grit and sand particles are usually removed from water by which type of settling? So this we have seen in the previous week also. So is it flocculent, discrete, hindered, or compression? So here we are talking about grit and sand particles. So which type of settling will be there? So we discussed this in detail in the previous class. So B. So definitely it will be a discrete particle settling. Okay. Because this will not interfere with each other and they will settle individually. So there is no point of coming in contact with each other or compression or to form the flocculants. This will all not be forming in this case, right? Next problem. Find the terminal velocity of a spherical particle with a diameter of 0.25 millimeter settling through water, and we have some data like the specific gravity, the g value, mu, and the density, everything is given. So you have to find out the settling velocity in millimeter per second. So can someone quickly tell me? So what will be the settling velocity? Please try it out. I'll wait for some time. If you have any doubt, you can ask me regarding this question or anything. So please try to calculate the settling velocity. Here all the data has been given. So you just have to calculate the settling velocity. No answer? Can someone tell me how to approach the question? Any idea? Or which formula to use? How to solve this problem? Anything, guys, please. You have to answer something, or else there is no point of me writing all the formulas and just speaking by myself. Anyone, which formula to apply, how to proceed with the push question. We have solved so many problems in the last week. Similar type, similar type, but different problems. Any idea? Please, I need an answer from any of you. Which law to follow, what to do, anything. if you can tell me regarding this problem.
Sir, by using settling formula.
Yeah, like do you remember the formula? Any idea? Okay, okay, let me start off. So what we do when any kind of settling formula, settling velocity or anything or like of that sort is asked. Yeah, that is correct. We will start off with the Stokes law. We will consider that the particle will settle in a discrete manner, okay, and it will be a it will be governed by Stokes law. So that will be our initial thought process. But always remember that there are certain assumptions with the Stokes law, that the flow should be laminar. Okay, so that criteria should be met. But to find out whether the flow is laminar or not, we need the velocity. Okay, so first we will roughly calculate the velocity. So how we are applying the Stokes law? So what we will write? We will write considering Stokes law for laminar flow. So we are assuming that the flow is laminar, okay, and hence we are using the Stokes law. So the Stokes law, for the Stokes law, the velocity, the settling velocity is nothing but rho g into g minus 1 d square by 18 mu. So this is the basic formula. So we'll put the values 10 to the power 3 into 9.81 into 2.65 minus 1 into 0.25 into 10 to the power minus 3 whole square by 18 into 10 to the power minus 3. So uh, this is how we have to put the formula. So now the settling velocity that we will get is 0.0562 meter per second, or it is 56.203 mm per second. So many of you will say that, okay, so this is the answer we got. So this is the settling velocity. You will mark it and you will forget it. Okay, you will mark it as right answer, that this would be the settling velocity. But always remember that this is only true when the flow is laminar, or if Stokes law is explicitly uh, applicable. Okay, it is told in the question, but in our question there is nothing mentioned whether the flow is laminar or Stokes law is governing. Nothing is mentioned. So we have to check it whether our assumption is correct. So for checking it, what we will do, we will check for Reynolds number. So flow type we will check by Reynolds number. So what is Reynolds number? So Reynolds number NR is nothing but the rho into the settling velocity into the diameter by mu. Okay, so this is the formula. So what we will do, we will put it the values. So when I put all these values, I get the Reynolds number is 14.05. Okay. Now tell me, is the flow laminar? What do you think? Is the flow laminar? How can you say the flow is laminar? What is the range of laminar flow for Reynolds number? Is it for a is it for this kind of particle settling, or whatever you are saying, is it for a pipe flow? So I think 2000 is for a pipe flow. Okay, this is not a pipe flow. Yeah. So here the laminar, for laminar flow it should be less than 1, but it is not. Okay. So since it is greater than 1, it's a transitional flow, right? So it's a transitional flow. So that means, so what happened now is that the assumption that we made that it's a laminar flow, it is now not true. Okay, the assumption itself is not true. So this cannot be my settling velocity. This cannot be my settling velocity. So what we have to do, we have to improve. We have to improve or change with more and more iterations. We have to get to the, so that means the Stokes law is not valid. The Stokes law is not valid, whereas the general uh, formula for the velocity will be applicable. So this formula is given for the Stokes law, but we have to apply the general formula. So just make a note of it. So whenever, based on our type of flow, my NR, okay, that is the Reynolds number, and the coefficient of, what is this, CD, drag coefficient, it will be changed. So this CD will be required for the general formula. So that's why I'm telling you. So if the flow is laminar, okay, the Reynolds number should be less than 1 and drag coefficient should be 24 by NR. Okay, if the flow is transitional, Reynolds number should be 1 to 10 to the power 4. Okay, and the CD is 24 by NR plus 3 by root NR plus 0.34. So I am telling you the formulas for all of this. And if the flow is turbulent, NR should be greater than 0 10 to the power 4 and the CD value is 0.4. So that's how you have to find out the Reynolds number. So now we have seen that our flow is a transitional flow. Okay. So now what we will do, considering transitional flow, we will find out the CD, drag coefficient. So what is my transitional flow CD? It is 24 by NR, that is 14.05 plus 3 by root NR, root 14.05 plus 0.34. This will be 2.85. Okay, right? So this will be my CD. Now what will happen? Now we have to find out the settling velocity again using the CD value. We have to find out the settling velocity again. So now we will not apply the Stokes law. We will use the general equation for settling velocity. So the general equation is Vs square is equal to 4 by 3 GD G minus 1 by CD. So this is the general equation for settling velocity. Or you can also write it as Vs is equal to root over 4 by 3 GD into G minus 1 by CD. Okay, so just put in the values. So if you put in all the values, you will get it as 0.043 meter per second. Okay, so now this also is not equal to our 0.05x meter per second, right? Whatever we found out. So like that, you have to make some more iterations. So this was my trial 1. This was my trial 1. Okay, so now again what we have to do, we have to find out the trial 2, so that this should match. This should match my previous answer, and this answer should match. So again trial 2, we will again calculate the NR. Okay, what is my Reynolds number? Rho v d by mu. Okay, then I will calculate the CD. Based on, I will see what is that, whether it's a transitional flow, laminar flow, or turbulent flow. I will calculate the CD. Then with the help of CD, I can again calculate the VS. And this VS should match my previous VS. It should match my previous VS. Then only it is correct. If it is not correct, we will go for again trial 3. So it's a kind of iterative process. So in this question, if you go for 3 to 4 trials, you will get the final VSS 0.03. 1 minute. No, you will get it as 37 centimeter per second. So the final answer is 37 centimeter per second. I think it is not centimeter, it is millimeter. Okay. Yeah, millimeter. So 37, you will get the answer as 37. Yeah, 37 millimeter per second. Is it clear or any doubt is there in this question? Please let me know. Just go through it once again. Okay. Is there any doubt? Then I hope that it is clear to all of you, right? We'll move forward then. Okay, the next problem. The next question says that a water sample has a particle size distribution as shown. So we have two type of particles. We have zero point 0.3 size and zero point 0.4 size, and quantity is 40% and 60%, and their settling velocity is 0.25 millimeter per second and 0.3 millimeter per second. Now total solids that is in suspended form is 500 grams. Okay, so this is the total solids, and the design overflow rate is 0.3 millimeter per second. So now you have to find out the efficiency of the horizontal flow sedimentation tank with respect to mass removal in percentage. So all information is given. You have to find out the efficiency. So please try it out. I'll wait for some time and then we will discuss. So please you try to solve this problem. Okay. Then we will see how to go ahead. So here only two types of particles are given, zero point 0.3 and zero point 0.4. Okay, and their like amount is also given and their settling velocity is also given. And the overall design overflow rate or the SOR is given. So based on that, you have to find out how much particles will go undergo settling. So out of the 500 grams, how much will be settling, how much will not be settling. So based on that, we can find out the efficiency. Are you able to understand the problem? Is there any doubt? Okay, if none of you are able to solve, we will just see how to go ahead with this problem. Okay, so the correct answer is 93.33%. We will see how it comes. Okay, so first see. So we have two types of sizes. One is zero point 0.3 and one is zero point 0.4. Now, if you see the design overflow rate, it is given as 0.3 millimeter per second. Okay, and the settling velocity of zero point 0.4 size particles is also 0.3 millimeter per second. Okay, so that means that all the particles which are of 0.4 millimeter size, okay, they will definitely be settled because the size is equal to the, because the design overflow rate is matching with the settling velocity. So whatever particles are there of that size, they all will get settled. So how much is the particle present of zero point 0.4 size? So it is 60%. 60% of what? 500 grams. So out of 500 grams, so 60% of 500 grams will be equal to 300 grams. So out of 500 grams, 300 grams will definitely get settled in the system. So this was about the particles of 0.4 mm size. Now what about the 0.3 mm particles? So the uh, so so the removal percentage will be based on the settling velocity. So settling velocity is given as 0.25 and the overflow rate is 0.3. So we will divide it. Okay, we will divide 0.25 by 0.3. So we will get it as 83.33%. Okay, so that means out of the particles which are of 0.3 mm size, 83% will get removed. Fine. And if we find out how much is the 0.3 mm particle size, that is 40%. So 40% of 500 grams into 83%. So it will be equal to 166.67 grams. Okay. So out of the leftover 200 grams, which was of 0.3 mm size, 166.67 grams will get removed. So total removal will be 300 plus 166.67, that is 466.67 grams. So final efficiency will be 466.67 divided by 500. So that is 93.33 percentage. Is it clear to all of you? Is there any doubt? Anyone? You just have to compare the settling velocity with the design overflow rate. If it is equal to or more than that, then 100% it will get removed. And if it is less than that, then you have to find out the ratio based on the ratio of the settling velocity to the SOR. So that many particles will get removed. Okay, very simple. I hope it is clear to all of you. Okay, we'll move forward. Okay, again a very small numerical. The aeration tank in wastewater treatment plant contains mixed liter volatile suspended solids or the MLVSS concentration of 3000 milligram per liter. The plant receives a primary effluent with a biological oxygen demand of 208 milligram per liter and a flow rate of 12 milligram per liter. The aeration tank has a volume of 1875 cubic meters. You have to find out the F by M ratio. So direct formula application. What is F by M ratio? Just input all the values and tell me the answer. I'll wait for a minute. Please let me know the answer. What is the formula of F by M ratio? Can someone tell me? 0.44 per day. Okay, let's see the answer. So that is the correct answer. But it should not be in per day. F by M ratio doesn't have any units. Okay. Okay, no, I don't think. Uh, no, I think unit will be there. Yeah, yeah. It will should be per day. It will come and per day only. Yeah. I think there is some mistake. So QS not by VX is the correct answer. Is it fine? I hope for others it is clear. Okay, we'll move forward. Wastewater has various kind of nutrients present which can be used by microbes for cell synthesis. Select the nutrients which are categorized as the major nutrients. So we have sulfur, phosphorus, calcium, sodium, nitrogen. So which of them are the major nutrients? So what do you think? So we are talking only about the major nutrients, not the micronutrients. B and C. Is it B and C? So basically the major nutrients are nothing but phosphorus and nitrogen. Okay. So these are the most commonly found and the major nutrients, B and E. Definitely, yeah. Next problem. Which of the following is not a step in the activated sludge process? Mixing and aeration of mixed liquor, settling of mixed liquor to separate the sludge, anoxic conditions for denitrification, drying of the sludge, flocculation of the mixed liquor. So which of them is not a step of ASP? Very direct question. Please give the answer as soon as possible. Just D. So definitely drying of sludge is not a part of the ASP. So if you see, this is the basic flow chart of an ASP. We have the aeration tank where the mixing and aeration will happen. Then the clarifier where the settling will happen. And within the aeration tank, sometimes there will be a denitrification zone. So before that, we can have an anoxic condition where the denitrification will happen. Then we have the drying sludge will is not a part of the ASP, and flocculation of mixed liquor. So this can also happen in the clarifier. Okay. So drying is outside the scope of the activated sludge process. Though it is a part of the whole treatment system, but not within the activated sludge process. Okay, next problem now. The composition of the total gel-dal nitrogen or the TKN in domestic sewage is expressed in milligram per liter as nitrogen, which is the result of addition of. So what does TKN consist of? Nitrogen from both organic and inorganic, by nitrogen from organic sources and nitrite, nitrogen from organic sources and ammonia, or ammonia and nitrite in the sewage. So you have to tell me what total gel-dal nitrogen consists of. So definitely it will be only C. So both organic sources and ammonia are the part of the TKN. So we will define TKN as the measure of the organic nitrogen plus the ammonia nitrogen that is present in the system. Okay, again a direct question. So here also all the parameters are given: flow, influent BOD, HRT, biomass concentration, everything is given. You have to find out the MLSS. So a similar problem we have done just few questions back. So the same formula is applicable. A little change will be there only, and you can find out the answer. So please calculate and let me know the correct answer. I will wait for some time. So a very similar problem we have done. In that question we calculate the volume, but here they are asking the MLSS concentration. So the same formula, just a small change we have to do and we can find out the answer. One nine eight 2.6. Okay, let me check. Yeah, that is exactly the right answer. Very good. So again, this is the formula which we have to apply. So it is x is equal to y into s naught minus s theta c divided by 1 plus kd theta c into theta. So in the previous problem we have seen when we are trying to find out the volume, so it was v into x. So here it is directly x because v, if you take it to the right hand side, so in the earlier problem there was a q, so q by v, so we can replace it with theta. So that's why that theta is coming in the denominator. So theta is nothing but the aeration tank HRT. Okay, so if you input all the values, you will get the answer as 1982.6. So that is absolutely correct. I hope it is clear to all of you. I think there is a small typo error. It should be 1 plus 0.05. It is 1 equal to 0.05 is written. So it should be 1 plus 0.05. Okay, that's all. Next problem. Okay, again, similar problem what we have done in the previous. So I have given you the formula. So this time you please calculate and tell me what is the average oxygen transfer rate. So a very similar problem we have done. Okay, so please tell me the average oxygen transfer rate. So others also please try. I am seeing that only one person is answering again and again. So others also please try and let me know the answer. You already have the formula, everything. So tell me the final answer. No one with the answer. 21.2. Okay. Yeah. So almost correct. 21.16. So that is correct. So again, similarly, we have to first find the C average with the formula, then we have to find out the average oxygen transfer rate. So very similar type of problems. Just a minute, just wait for 2 minutes. Okay, so I think you have already read the question and given the answer. So all of them will be the correct option because all the pH, temperature, and surface overflow rate will govern the efficiency of the coagulation based sedimentation. Okay, so as you know, the different coagulants will govern or work at a certain pH range. Like you can see, like the aluminum coagulants will effectively work in the pH of 5 to 6.5, whereas the ferric coagulants will work in the pH range of 4.5 to 6. So they all have their own pH ranges. Okay, and also low temperature can slow down the coagulation process as reflected in the decrease in aggregation rate, okay, or the rate constants, and increased SOR can also reduce the coagulation efficiency. So all of these factors will govern the coagulation. Next problem. During secondary treatment of wastewater, the effluent from the primary clarifier enters the, so very direct. So influent from primary clarifier will enter the aeration tank, secondary clarifier, disinfection tank, or none of the above. Please tell me the answer. No, here we are talking about the primary clarifier. So from primary clarifier, where it will go? So after the primary treatment, what will happen? Just think about it. Again, guys, just think about it. From the primary clarifier, it will go for secondary treatment. That is correct. Okay, but does it go from directly from primary clarifier to the secondary clarifier? In between, one more unit is there, right? So think in that aspect. So after the primary clarifier, it will enter to the secondary treatment. So what will happen first in the secondary treatment? What is required? Secondary treatment means biological degradation. So what will happen? What is required? For biological treatment, what is required? Oxygen. So for oxygen, where it will go? It will go to the aeration tank. So that's why A is the correct answer. Okay, so please be careful with the terms. After primary clarifier, it will not directly go to the secondary clarifier. It will first go to the aeration tank where the degradation will happen, and then it will go to the secondary clarifier where the flux will be settling down. Okay, so that's how it should be. So please be careful. A probable electron acceptor in anaerobic anoxic respiration is organic matter, nitrate, sulfate, all of the above. So in the case of anaerobic anoxic respiration, what is the electron acceptor? So in aerobic system, it is the oxygen. So you have to find out for anaerobic anoxic system. So what can be a electron acceptor? So definitely D, all of them, because all organic matter in the case of anaerobic and nitrate and sulfate in the case of anoxic. Okay, so both will be, so all of them above is the correct answer. Advantages of biological treatment processes over physicochemical processes are cost effectiveness, lower energy requirements, both A and B, less time consuming. So you have to find out the advantages of biological treatment over the physicochemical process. What will be the advantages? C. So both A and B, because as you all know, biological systems depend on the microorganisms, so cost effectiveness is there. It will be very cheap, whereas physicochemical processes will depend on many chemicals, okay, reactors, all those things will be there. So it will be more costly. And also energy requirements, because to run some mixers, pumps, and all those things in physicochemical treatments, energy will be more. Whereas for biological, it is simply bacterial degradation. Whereas the biological treatments will be very much time consuming. Okay, it will take more time for the microbial degradation to happen. So that's why both A and B are correct options. When organic matter is used as an energy source, it is converted into stable end products by the process of anabolism, catabolism, catalysis, pyrolysis. So which of them is the correct answer? Is it catalysis? Just think again once more. So it is called as catabolism. So when organic matter is used as an energy source, it is converted into stable end products by the process of catabolism. So please don't be confused between catalysis and catabolism. Okay, catabolism is a process that is done by this bacteria also. Okay, so this organic matter is used as an energy source in that. Next question. Endogenous respiration is a process of derivation of energy required for cell synthesis exclusively through oxidation of organic matter by microorganisms or is it derivation of energy through the oxidation of their own protoplasm by the microorganisms, or derivation of energy for synthesis or from inorganic substances, or from photosynthesis by the microorganisms, or all of the above. So just think about endogenous respiration. So whenever there is a microbial growth, so in the end phase, there will be some endogenous respiration that would be happening. Okay. So what does it mean? How can we define it? So when we talk about endogenous respiration, it is oxidation of their own protoplasm. Okay, the microorganisms will start kind of dying. They will feed onto each other, or the oxidation of their own protoplasm will happen. Okay, whereas the first one is their kind of processes for for sustaining. Okay, they will derive energy by oxidation of organic matter. So we saw catabolism. But here, when we are talking about endogenous respiration, the oxidation of their own protoplasm will happen. Okay, so option B is the correct answer. Identify the most appropriate choice for statements A and B. The nutrient requirement is lower in anaerobic processes than in aerobic processes. The growth rate of microorganisms is lower in anaerobic processes. So which of them are true, false? You have to tell me. So here we are comparing anaerobic and aerobic processes based on the nutrient requirement and the growth rate of microorganisms. So actually here both statements are true. Why I would tell you? Because in any aerobic systems there is a generation of more ATP. Okay, and ATP is nothing but the energy source. So more ATP is generated. So because of that, the growth rate will be very high. Okay, in the case of aerobic. In the case of aerobic. And because the growth rate is also high, the nutrient requirement will be also high in case of aerobic. That's why for anaerobic processes, both of them are lower as compared to the aerobic processes because the ATP generation is lower. Okay, so here also I have given nutrients are required for the synthesis of new biomass. However, generated ATP is low in anaerobic process. Therefore, the nutrients required in low due to the growth rate. Please re-explain the question of average oxygen transfer. Okay, average oxygen transfer, right? I will just go back 1 minute. Okay, so here if you see the question, so generally just remember that for when we are finding out trying to find out the oxygen transfer rate of any aerator, so generally the standard transfer rate will be given by the manufacturer or by the company. Now based on the elevation, the temperature, the pressure of that particular location where we are going to fix this aerator, the actual or the average oxygen transfer rate will change. Okay, so here you can see that the standard oxygen transfer rate is given as 36.5 kg O2 per hour, but whereas the average is only 21, so it has decreased based on the temperature and pressure. So first we have to find out the concentration of this oxygen at a particular pressure, depth, and the oxygen concentration. Okay, so based on that, first we will calculate the C average. So direct formula: what is the concentration of oxygen at a particular STH, and then what is the full depth pressure, what is the atmospheric pressure. So if you input all the values, you will get the C average, that is the average concentration of O2, okay, in the system, average concentration of O2. Now we have to
Sir,
find out the transfer rate. Yes, Mohan.
sir, sir, OT upon 21, है ना?
हाँ.
Oh, please explain 21. I can't understand.
21 देखो, in air, what is the oxygen percentage?
Oxygen percentage.
It is around
Here
21
90,
percentage.
19%.
No, no, in actual mostly we will take it as
Ah, in
21.
actual 21%.
Yeah, so that's what we have put it, 21.
Okay, this is a constant value.
Ha, this is a constant value.
Okay, sir. Thank you. Thank you.
Okay, fine.
Fine, sir. Fine.
Ha, okay. So we were in question, I think. Yeah. This question is sludge volume index we have already seen. Okay, I think two, three more questions we can solve. Okay, so identify the correct statement regarding the activated sludge process. So here we are comparing the extended aeration and the conventional ASP based on the F by M ratio and the HRT SRT. Okay, so you have to tell me which one will be higher or lower. So go through the statements and tell me which one is correct. So first one says that the F by M ratio of extended aeration is higher than conventional. Then the second one says that the F by M ratio is lower for extended aeration. Then HRT is lower for extended aeration, or the SRT is greater for the conventional ASP. So you have to tell me which one is correct. Just think logically. So if you see the extended aeration, we are aerating it for a long period of time. Okay, we are aerating it for a long period of time. The processes are going on long period of time. So that means the HRT should be more. Okay, HRT should be more. So statement 3 is incorrect. Then SRT also, what happened in the case of SRT? SRT is the sludge retention time. So the sludge retention time should be more for extended aeration only. And if we talk about F by M ratio, the F by M ratio will be lower. Why? Because the amount of food that we are providing with respect to the microorganisms will be lesser in the case of the extended aeration. Because what will happen, for long period of time, the microorganisms will be taking the food, and after a point of time it will go endogenous respiration. So it is extending the aeration time, so the food concentration will be comparatively lower in case of the extended aeration time. Okay, so that's why option B is the correct answer. Okay, another question: the degradation of organic matter in biological processes is typically due to photoautotrophs, photoheterotrophs, photoautotrophs, or chemoautotrophs or chemoheterotrophs. So how does the organic matter degradation happens? So photo means with respect to sunlight, chemo means by chemically, by some chemical energy. Okay. Is it photoheterotrophs? Do you think all the treatment processes are based on sunlight? There are some organisms that are based on sunlight, but most of them are chemoheterotrophs because they will use the organic matter as the electron acceptor. So that's why they are heterotrophs. And then it will be a chemically derived function. Okay, so it will be chemoheterotrophs, right? So this is how the answer would be. The rate of microbial growth and metabolism depends on food by microorganism ratio, solid retention time, sludge volume index, none of the above. Very direct question. You have to tell me on what the microbial growth and metabolism will depend on. Okay, so definitely it will be the food to microorganism ratio. Okay, because other things will not regulate the microbial growth and metabolism. It will be only the amount of food per microorganisms you are providing. Okay, again, this is the same sludge volume index. So you have to just divide by the volume by the mass. So 27 by 3, it will be 9. So that is the correct answer. Right? Okay, so we'll stop here for now because I think I have solved enough problems today and I have tried to cover all the MCQs. And there are few more questions given in the slide. You can go through if you want. SRT problem. What SRT problem? Can you elaborate?
Sir, sludge retention time calculation, sir. Theta C equal to Vx by Q minus QW into that
Yeah,
problem. Sir.
yeah. So you want me to solve that? Actually, I don't think I have a similar problem, but yeah, the whatever formula you are saying is correct. So you can directly apply that formula and find out the answer. Is there any problem in that? Where are you facing the? Do you have any problem similar which you are facing any difficulty?
Sir, yeah, in theta C, two problems are two formulas are, sir. In two formulas, where is applicable, sir? That.
Yeah. So see, based on the data given in the questions, you have to apply the formula. In many of the times, suppose your this this XC or all this XR, QW, QR, everything is given, then that big equation will come into the picture. Okay. Or sometimes if only mu is given, then 1 by mu is equal to theta c. Like that also you can do. So based on the data given in the question, you have to approach. If you have any further difficulty in solving these kind of problems, you can send me the problem over mail. Okay, my mail ID is given saha19akash@gmail.com. So you can send me the problem. I will look into this and tell you how to approach. Is it fine? Okay. Anyone else if they are having any problem? So we will have again another class next week, same time, 7 to 9 p.m. on Tuesday, 25th February. So see you again that time. If you don't have any questions, you can leave the session. So that's all from my side for today. Thank you, Mohan. Thank you, Priyanka.